Welcome back. Let us go through the question. A man walks on a straight road from his home to market 2.5 km away with a speed of 5 km per hour. Finding the market closed, he instantly turns and walks back home with a speed of 7.5 km per hour. What is the magnitude of average velocity and average speed of the man over the interval of time 0 to 30 minutes, 0 to 50 minutes, and 0 to 40 minutes? And there is a note. You will appreciate from this exercise why it is better to define average speed as total path length divided by time and not as the magnitude of average velocity. You would not like to tell the tired man on his return home that his average speed was 0. So, you know what? There is an important lesson incorporated with this particular exercise. So let us go through that. The time taken by the man to reach the market is T1. So the T1 would be what? We know V is equal to S by T. So T is equal to S by V, right? So here the S is 2.5 and the V is 5. So the T1 is 0.5 hour, which is 30 minutes. So displacement in 30 minutes is D1, which is 2.5 kilometer, and the magnitude of average velocity is d1 by t1, which is 5 km per hour. And for the second one, the distance traveled in 30 minutes is 2.5 km, which is denoted by s1, and we can know the average speed is equal to s1 by t1, which is 5 km per hour. The first 30 minutes the man travels from his home to the market. During the next 10 minutes, he travels with a speed of 7.5 km per hour towards his home, covering a distance s3. Now, what is this s3? The distance he travels in the next 10 minutes with a speed of 7.5 kilometers. So we can easily find out the value of s3 by multiplying 7.5 with this 10 minutes converted into hours, 10 by 60, right? So the s3, the value of the x3 would be 1.25 kilometer, and the next time which is given in the question itself is 40 minutes. The magnitude of average velocity would be 2.5 minus 1.25 divided by t3, which is equal to 1.875. So the average speed is 2.5 plus 1.25 divided by T3 equals to 5.625 km per hour.